In this video, we're going to solve 4 questions consisting of main memory designing in a computer. Before we get to these questions, we need to know what they are. This is RAM and ROM. They generally come in units called chips or blocks. For example, this RAM chip consists of 128 words and each word is of 8-bit each. It has 5 inputs: chip select 1, chip select 2, read, write, and a data bus, address bus of 7 bits. Chip select 1 should be high and chip select 2 should be low for this particular block to be selected. It has a 7-bit address bus because it consists of 128 words. 128 words is 2 power 7 words, so it needs 7 bits of address lines for the memory. Next is ROM or random access memory. This particular unit consists of 512 words of word length 8 bits. It has chip select 1, chip select 2, and a 9-bit address bus. It has 9-bit address bus because 2 power 9 is 512, which has 512 words. Next, first question. You are given the task of designing a microcomputer with main memory of 1K into 8, of which 512 words are RAM words and remaining 512 are ROM words. You should make use of appropriate number of 112 into 8 RAM and 512 into 8 ROM chips to design the main memory. So the upper block consists of the CPU, which has an address bus, a data bus, and a read instruction and a write instruction. So we need to use 128 into 8 RAM blocks to make 512 words of RAM. So 128 into 4 is 512. So I've included 4 units of RAM bits of 128 words each. Now, the read instruction is connected to the read input of all the 4 and to the ROM bit. The write instruction is connected to the write input of all the 4 RAM bits. Next, the 7-bit address bus is connected to all the RAM units and the ROM unit. Next, for the 8th and 9th bit of the address bus, we use a decoder to select which RAM should be selected, the first chip or the second chip. So if the 8th and 9th bit is 00, the RAM 1 is selected, or else if it's 01, RAM 2 is selected, if it's 03, RAM 3 is selected, if it's 11, RAM 4 is selected, and so on and so forth. The 10th bit is used to select if you want to use a RAM or ROM. Suppose the 10th bit is 0, the RAM is selected. If it's 1, the ROM is selected. And the 8th and 9th bit is also fed to the ROM bit to make a 9-bit address bus. And that's about it for this question. Moving on to the next question. The second question is actually you are given the task of designing a microcomputer with main memory of 1536K and 8, of which 1024 words are RAM words and remaining 512 are ROM words. You should make use of the appropriate number of 128 into 8 RAM and 512 into 8 ROM chips and design the main memory. So 1024 words should be of RAM words. So 128 into 8 is 1024. So I included 8 RAM bits or chips, but I didn't have space, so I put the 8th one at the end. So it's almost similar to the last question. The read bits is connected to the all the 8 chips of RAM and to the ROM. The write is only connected to the 8 RAM chips, 1 to 7. The 7 bits of the address bus is connected to 8 bits of RAM, and to the ROM, the 8th, 9th, and 10th bit is used to select which RAM chip you want to read at the time. So if it's 000, it's the first one, 001, the second one, 010, the third one, and so on and so forth till 111 is the 8th one. Then the 11th bit is used to select whether you want to use the RAM or the ROM. Suppose the 11th bit is 0, it's connected, it'll read the RAM. Suppose it's 1, it'll read the ROM. And the 11th to 17th bits is used as the address bit. So this is the final question. Okay, third one. In case you are asked to design a 2K into 8 memory with 512 and 8 ROM and remaining RAM area, how many 112 into 8 RAM and 512 into 8 ROM chips are required? So this is a pretty easy question. So we have 2K, which is 1024 into 2, 2048. In this, 512, 512 words are RAM. So we need to use 1 512 into 8 ROM to make 512 ROM words. Remaining is RAM. So we already used 512 as ROM words, so 2048 minus 512, 1536. So 1536 words divided by 128 RAM chips, chip space. So 1536 divided by 128. So we need 12. 128 into 8 RAM chips. So 12, 128 into 8 RAM chips and 1 512 into 8 ROM chips are used to design 2K into 8 memory. Next is the final question. I'll do it here. Okay. If you are asked to design a 2K into 8 main memory for a system to be designed with 1K into 8 RAM and 1K into 8 ROM memory chips, state how many 128 into 8 RAM and 512 into 8 ROM chips are required. This is similar to the last question. So 2K into 8. In this, 1K into 8 should be RAM. 1K into 8 should be ROM. So 1K, which is equal to 1024 words, divided by 128 word chips, which is equal to 8 chips. 128 into 8 chips. Next, 1024 words divided by 512 word chips. So 1024 divided by 512, which is equal to 2. 512 into 8 chips. Therefore, 8 128 into 8 RAM chips and 2 512 into 8 ROM chips are used to create 2K into 8 main memory. 2K into 8 main memory. Thank you.